Hello again, there again, class. This is Noah Housley of just my own study help, but maybe it can benefit you guys too. Here is problem set number 3. I'm not going to talk about the whole thing. This one was definitely shorter, but let's see what we learned from this one. First, really basic. When you're given an isotope of an element, to find out how many protons, neutrons, and electrons this thing has. First thing to know that this up here is the mass number. It's usually the rounded mass of the element, hence the mass number. And this is the secret to everything. To find how many protons, it's going to be the mass number minus the number of neutrons. Excuse the handwriting, that's number, that's a hashtag. Minus number of neutrons. The neutrons are the opposite, mass number minus the number of protons. And the electrons are the tricky one. It's the number of protons unless there's a charge. In this case, there's a charge. It says a 2 positive. If there's a plus sign, that means that there's less electrons. So in this example, it's 2 less. If there's a minus sign, so if it said 2 minus, that'd be a negative charge. That means a minus sign is more electrons. And in that case, it'd be 2 more because it's 2 negative. Then in relative to protons. Everything's kind of relative to protons, so it's kind of nice. Okay, one of the problems on the problem set this time was asking this. It said, how many neutrons are in 10 grams of fluorine 19, the only stable isotope of fluorine? Okay, so remember from the last dimensional analysis video, when you're doing dimensional analysis, start with what you have. They said we have 10 grams. Let me get a better angle here. $10 grams. Okay. So, what else do we need to know? If we have 10 grams of fluorine, okay, what are we going to multiply by? Well, first of all, what's it asking for? It says how many neutrons. So we know we're going to have neutrons at the end. Spelled it wrong. Neutrons at the end. So that means we want to get to maybe atoms and then to neutrons. So how do we get to the atoms? Okay, well, we know that there's a mole of atoms, right? So 1 mole has 19 grams of fluoride. We got that from the mass number, fluoride 19, but also the periodic table. If you look at that, it'd be 19. And you know that the periodic table, the number below it or the mass number is that if there was a mole of that atom, it would weigh that much in grams. So we got 19 grams there. And so now we got to get rid of the mole. So in 1 mole, there's 6.022 times 10 to 23rd atoms. Hey, we're close. We just need to see how many neutrons are in an atom. So running out of room here. Let's ignore that equal sign. Let's get rid of the atoms. So we want atoms on bottom. We know we want neutrons on top. So now how many neutrons are in a fluorine atom? It turns out because there's 9 protons and it's fluorine 19, there are 10 neutrons for every 1 atom of fluorine. Multiply across, we get 3 because of the 1 sig fig times 10 to 24th neutrons. Hopefully that made sense. Just again, start with what you have, think of what you want, and then go with what you know. You start with, well, how do I get rid of grams? Well, I know that there's 19 grams of fluorine in 1 mole. Okay, well, now get rid of the mole. Okay, well, I know there's this many atoms in 1 mole. Okay, now get rid of the atoms. Okay. And so on and so forth. Sometimes you need to skip a step. You can go, well, I know there's 1 mole in 19 grams of fluorine, and I know that there's 10 neutrons in 1 atom, and then maybe that will click in your mind like, oh, that means I need to get rid of atoms. And so you can think, oh, okay, I need to get rid of the mole, and so on and so forth. So just think about, what do you have? What do you want? Start with something you know, and then think of how to get rid of the next thing. Maybe go one step in from each side. So 10 grams of fluorine, go one thing in. What do I know? Neutrons, okay, what do I know? I know that there's 10 neutrons in one fluorine atom, and things like that. Start with that. Okay. Now we're going to talk about the last problem, number 6 on this problem set. It says, a single gold atom has a mass of 197.0 AMU. How many gold atoms are in a cube of gold that is 10 millimeters on each side? If the density of gold is 19.3 grams per centimeter cubed. Okay, and then it gives us a number that we'll need to make the conversion. All right, on this problem, just think, what do you need? Okay, so on these kinds of problems, think, okay, what do I need to make this work? What do I need to do some dimensional analysis? Okay, because I can't, right now, I have, what I have is 10 millimeters. Oh, that's a 10. 10 millimeters